Welcome to the first lecture, or the first part of it. It's in the form of summary. A voiceover was done later. The topic of it deals with toys. Architectronics will be addressed in the second part or B part of the lecture. So let me begin with a schedule. The schedule we start with 3 lectures, 3 consecutive periods devoted to lectures, and followed by the studio workshop, where work will be done with group and so on and so forth. I just want to bring to your attention the yellow polygon on the right, which says VDS. Those are the thresholds, deadlines, or if you like, pin-ups, where you expected to publish current state of your work or concepts or developments on internet, on a WordPress portal, which is was developed for you by Mr. Markusiewicz, and we use it as a format to publish our work and to, I guess, have a form of blog for feedback and comments between students, team members, other teams, as well as tutors. So let's all participate. Second part of schedule goes well into the end of a term. We will have the hand-in of this project in January, but there will be intense workshop period when the prototypes will be developed. Let me address the topic first. We are dealing with robot toys, with toy models. So the toy is an interesting notion because in science, toy model stands for a simplified set of objects used to understand mechanism or some simplified theory, or non-simplified theory, full theory. In the toy and mathematical models is usually done by reducing number of dimensions or reducing number of variables or restricting them to particular symmetric forms. Toy physical descriptions an everyday example of an analogous mechanism is often used to illustrate effect in order to make the phenomenon easier to visualize. Phrase even tinker toy refers to this classical children construction toy, with which objects can be built easily, and the process that facilitates learning, though it restricts the set of things that can be built, of course, because it's a systemic type of toy. So in mathematics, the toy theorem is a simplified version of more general theorem. For instance, by introducing some simplifying assumptions, one obtains a toy theorem. You actually get a model of a problem. So this is we're looking at the Lego, and a Lego right now has a version of the toy called Mindstorms, and that's actually fully interactive construct with which robotic, if you like, toys could be built. Here is one. In many disciplines, a toy problem is not of immediate scientific interest, yet it is used as an expository device to illustrate concept which might be shared by other, and as well explains particular more specific problem-solving technique. While engineering of large system, the large problem is often broken down into many smaller toy problems, which have been understood in good detail. Often those problems distill a few important aspects of complicated problems, so they can be situated in isolation. So let's remember that the notion of a certain degree of abstraction or reductive depiction of larger problem with a smaller toy problems. I think it's interesting intellectual idea in design as well. In artificial intelligence, puzzles and games are often used as toy problems. They include the sliding block puzzles, tic-tac-toe, and other. Um, Model, of course, is a representation of system made of composition of concepts which are used to help people to understand and to simulate the subject of the model represents. Um, Conceptual models are often abstractions of things in a real world, whenever whether a problem is physical or social. On the left, we see Tinker Toy. On the right, we see another Robol toy, uh, which we will explain later. Perhaps I have a clip of the movie. That's a Tinker Toy, as you see, advertisement from 30s from American paper, an already electrical engine, and kinetic models could be built with the system. Let's look at Meccano, which which has a fully interactive kit from which fully interactive robot could be built. Here we see one instantiation of it, but it's programmable and it has all the characteristics of a serious project. It remembers movement and recalls audio, and also is interactive with the iPad, and also accommodates iPhone and things like that. Mirrors movement of the designer. Many possibilities with this toy. I think its market price of it is around $1,000, I guess, not zlotys. Okay, here's another one, and few other possibilities with this mechanoid or mechano toys. Well, our first problem set after brainstorming would be to design robot toy, and I hope that we will be able to utilize not only construction and system of some form so the toys could be aggregated, but also control system. So it's with embedded electronics and sensors, actuators. I would like us to also explore possibility to utilize Bluetooth Smart. This is interesting protocol recently proposed by Apple, developed by Apple. Those are form of beacons, low energy, Bluetooth. It's called BLE. And those broadcasts small range identifiers, and technology enables smartphones, tablets, and other devices to perform actions when in close proximity. So, if you consider in your robotoy interactivity, iBeacon might be a good possibility to explore. Those are low energy, intelligent um, kind of sensors, um, and they are smart as they are aware of electronic equipment which can be subscribing to this protocol. Here, the potential of it is very, very large. We see it used in part of a head display, meters, electrical meters embedded in the cars, and also increasingly embedded in toys. This new generation of equipment um, is interesting because it has a wide range of new applications, and in fact makes many our daily products connected, and that's where the concept of Internet of Things is important to address. This is an article which I'll put it on our uh, website, which is worth to read. This is by a Harvard professor who addressed political and social implication of Internet of Things, and it's very interesting because a few days ago there was a big break-in into the internet in a few American companies, and I think the way it got into that system was through the peripherals, like in this article. The prof, whose name escapes me at the moment, I think Powell. No, Powell is I think is not his name, but anyway, whatever his name, he says Internet of Things might be a way to drive efficiency. It is also deployment of the most sophisticated surveillance state that has ever been. As you design those things, you are making policy decisions. He actually, Professor Waldo is his name. Policy are somewhere between 3 and 2 weeks behind, 2 years behind what we are doing. Stop. Internet of Things is not without its problems and implicit dangers. Here's an article which I put on web. Recent lecture by Professor Waldo, computer science prof from Harvard, who says the Internet of Things might be way to drive efficiency. It is also deployment of most sophisticated surveillance system there ever been. So he quite rightly predict that there are dangers involved in unguarded deployment of this type of devices. And I think a few days ago we heard on the news about that break-in into one of American companies, which actually was um, accomplished through those peripherals. And all those argument is that policy and our social attitudes and policies are not way behind the technology, and we don't fully understand the implications of it. So, on a more positive note, I would like to return to the objective of our studio. Aim of our Robol studio is to experiment, and that's why Experimental Studios 3 has been always ambitious, has been ambition of Robol Studio was always to experiment, to take chance. The projects are situated at the intersection of cybernetics and architecture. the kinetic performative aspects of design together with basics of robotics and mechatronics are briefly addressed already in some of your other lectures. And as this studio will focus on speculative exploration of new technologies, it will focus on it will be an experimental studio format, and the design problem set will explore design of responsive environments. Intention ultimately will be to improve quality of life as well as simulate infrastructure of the urban environment of our century, which is emerging as we speak. Well, in the second part of this lecture, which is recorded separately, I will introduce notion of architectronics. This word is derived, as you can guess, from consideration of kinematics, mechatronics, and robotics, and architectural design as a discipline not fully established, but it's an important argument to some of my lectures. So we will, in a sense, explore architectonic practice of design in network environment, and we'll address, we'll produce drawings too, and computer simulation animations, working scale prototype models of selected fragment of your designs. Our goal is to explore a possible application of robotics to design, and each group, each team will benefit from experience of other groups, and with the end project resulting from this collaboration and collective process. For modeling, we'll use probably Rhino with Grasshopper, though Inventor and SolidWorks are also possible. We will use probably Firefly with Arduino as a controller, and I would like us very much to use Bluetooth Smart, as I mentioned. Devices it's anticipated in this Robol toy as a kind of paradigm for the Internet of Things. I guess in conclusion, I want to say that after this talk, we will attempt our first brainstorming and attempt first preliminary group formation. In the second part, I will deal with the issue of architectronics as I promised. That's it for now. Second part of the lecture is recorded separately. It's lecture 1B. Thank you.